Hey guys, back again with another excellent video on chemical calculations. And we're going to talk widely about chemical calculations in an advanced level embedded with this and Edexcel examination board. And we're going to talk about related questions, related past paper questions, and some of the predicted questions that might come for your exams in the future. So chemical questions is one of the most not most, but one of the challenging parts that students face in the examination. Myself, I myself it's kind of tough while doing this, chemical calculations in the part of chemistry, PS and Edexcel. So the practice is the required thing, and we're going to start the new lesson by knowing some of the required formula in the chemical calculations section in Pearson Edexcel. So in chemical calculations, you're supposed to know number of moles, number of particles, or number of ions, or number of formula units. Those parts are one of the most important things we have to know. How to calculate concentration of an substance, how to calculate concentration of an gas, or number of moles of a gas at a constant temperature. So we are supposed to know all of those stuff in this under this lesson. So let's start simply. Number of particles in a substance. So it's quite important to understand. Imagine there's a substance with three particles. But normally we are unable to count them physically because it's impractical. There are millions and millions of particles in an existing substance. So in that case, a person known as Avogadro introduced this constant mathematically, Avogadro constant. Now it's quite important to understand why Avogadro constant is quite important. Now, most of the theories embedded in the past have been proved wrong nowadays with the improving advanced science, and those theories have been changed without the name being used. Avogadro, standing one of the most profound names, has come up to the 20th century itself, gaining respect with his name and using his theories to explain number of particles in a substance. So the Avogadro constant that we are going to learn in Excel is 6.02 into 10 to the power 23. So in 1 mole of substance, now normally we are unable to really calculate the number of particles, but this is an estimation made by related to the carbon 12 atom. So the carbon 12 perfectly matches into most of the elements, and we are able to calculate number of particles related to carbon 12 atom. Get it? So calculating number of particles. So number of particles in an existing substance. We need to know the number of moles. Mole. Number of particles. Let's say NP, N capital P. Number of particles is equal to Avogadro's constant AC. AC is for Avogadro's constant. We'll have it in brackets. The Avogadro's constant times the number of moles. Now we can define moles. Number of particles divided by Avogadro's constant is moles. In that case, mole should be number of particles relating to Avogadro constant. So that's not the exact meaning, but they won't really ask the number of moles. To know more about moles, there's a link for all our researchers out there who are most curious in knowing more about chemistry. There are some of the reference links below in our description section. So moles we can calculate in a different way too. So number of moles is equal to mass over nmol. Now we can theoretically prove how it's equal to the number of particles divided by the Avogadro constant. Oh, we say this is equal to the number of particles to number of particles. Number of particles divided by the Avogadro's constant. MR, mass. Now, when we get mass of a normal substance, imagine there are 10 grams of hydrogen, and the MR is 1. Number of particles. Let's get another one. So let's get the atom sulfur, and we have 10 grams of sulfur, and the MR is 32.5. It varies; it can be 35.5 or 32.5 sometimes. This is the most accurate value. You can take it as 32.5. Or else if there's another value in your periodic table, you may use it. It's the third most mentioned, the MR value, or is the atomic mass of sulfur. Number of particles over Avogadro's constant. Now we are dividing a mass by mass. So this is related to Avogadro's constant. We see Avogadro's constant here. There is no such, so the masses and masses cancel off. Eventually we are left with Avogadro's constant. So actually, M over MR is also equal to number of particles divided by the Avogadro's constant. M over M1. Here are some of the questions that you may try right now. Pause the video and give it a try. So these are the questions, and you may try them now. Pause the video and give it a try. Use the number of moles and Avogadro's constant you can calculate. Okay, so calculate the number of moles of 15 grams of sulfur. We said that it's 32.5 M over MR. Mass is 15 grams. There is no SI unit is grams, so we don't have to do any conversions. So 15 divided by 32.5. That's going to be 0.461 moles. Hope you got it correct. So if they say there is no appropriate decimal place for any question, significant figures, but if they say appropriate significant figures, here you have to count the number of significant figures. It's 2, 1, 2. So identifying that, you have to leave it to 2 decimal places, 1, 2. So appropriate decimal place, if they give, it's 0.46. Else you have to leave it at least more than one significant figure, not one significant figure, more than one significant figure anything. If they don't ask. If they say appropriate, refer to the value they have given and count the number of significant figures available in them. Calculate the number of particles in 15 grams of sulfur. 15 grams of sulfur. In 15 grams of sulfur, that means 0.461 times 6.02 into 10 to the power 23 particles. 0.461 into 6.02 into 10 to the power 23. It's much better if you can multiply this entire block by the Avogadro's constant to get this value, but here we'll make it simpler and get it done. In the exam, you're supposed to do that. So the answer is 2.77522 10 to the power 20. There are this number of particles. Okay. So how to identify whether they are, say, ions, molecules, formula units, number of atoms, particles? Now we know if there is a number of particles, it could be molecules, formulas, or any of them. If there's a particles itself, you can refer to any of them, but you should identify what the particles they are referring to. So imagine I'll give you some elements and compounds, and let's identify what are those. Sulfur, the one we did before, magnesium, the metal, magnesium chloride, the ionic compound, and nitrogen dioxide, the gas, CH4, the gas, carbon, the known. This is sulfur and now sulfur, purely there are atoms, particles that present in pure sulfur, these atoms. Magnesium is a metal arranged with atoms. Now, nitrogen dioxide is a gas existing in molecules. These are existing in molecules. The particles here are molecules. So, gas, always molecules. If they ask atoms in molecules, then you have to count the number of atoms and then calculate for that. We'll do some calculations on that too. MgCl2, it's an ionic compound. We have formula units. Now, this is quite a new thing for you all, I guess. Or some of you all have heard it, but some of them might have not heard it. So, formula units always come in ionic compounds and not in covalent compounds, not really, but it can come in covalent compounds, but rarely. MgCl2, magnesium Cl2 is an ionic compound with strong electrostatic attractions between the anions and cations. Cation is magnesium and anion is chloride ion here. So now to form this entire MgCle packet, we need Mg and Cl because they don't purely show MgCl doesn't show Mg properties or either MgCl2 properties. It only shows MgCl2 properties all together. So here we are not considering Mg separately or either Cl2 separately, but we are considering it as a whole packet. So MgCl2, we consider it as formula units. Okay, we'll try another question. Again, post the video and you may try. Okay, so let's calculate the number of particles, number of formula units here they have mentioned in NaCl. They have given in 18 milligrams. How to calculate number of moles? They have not given in number of moles, so 18 divided by always when we calculate the number of particles, it's Avogadro constant into number of moles. So we have to calculate the number of moles here. It's milligram, we have to keep in grams. Milli to gram is 10 to the power minus 3. 10 to the power minus 3 divided by sodium, it's 22.9, 22.98. Plus C chlorine is 35.45 in the Alexa syllabus. Last time I used 32. Better use 35.5. Let's use that throughout the lesson. 18 into 10 to the power minus 3 divided by 2.9 plus 35.4 is 3.0, 3.0 into 3.08 into 10 to the power minus 4. It's going to be 0.000308747, etc. Now we calculated the number of moles. Remember to write mole. Now how to calculate the number of formula units in NaCl? You multiply 3.08 into 10 to the power minus 4 by the Avogadro's constant. We'll write Avogadro constant here. I'm writing 6.02 into 10 to the power 23. You have to remember. They might sometimes give you, but better to remember. So 3.0 into 10 to the power minus 4 is into 6.02 into 10 to the power 23 is 1.5 or 1.85416 into 10 to the power 23. Hope you got it. Final answer is 1.854 into 10 to the power. Okay, hope you all understood it. And let's move on to our next part. Now, there are different methods of calculating number of moles. Now, you can't use the same method to calculate the number of moles of a gas at a specific temperature they have given. So we are going to use N equals P over Pm. Number of moles is equal to volume of the gas divided by the molar volume. Molar volume they normally give, or is they might give you the number of moles and volume accordingly. You have to substitute and find molar volume. So molar volume, it can be 24,000. So we all know 1 dm3 is equal to 1000 cm cube. So they can give either 24,000 cm3 or 24 dm. So accordingly, you have to calculate number of moles, volume. Example, 5 cubic centimeters of some gas. Let's say chlorine, 5 cubic centimeters of chlorine, and it is given in cubic centimeters. And then you use 24,000 cm. They might give either way, but use them accordingly. Answer is 2.0833 into 10 to the power minus 4 pm3. Moles, number of moles. Sorry. Let's go into some of the questions we require in this section, and we'll understand further. Pause the video again and try these questions. Let's try this question. It should be Cl2 here. Cl2 gas. Calculate the number of moles of 20 cubic centimeters of Cl gas at our room temperature, and they have given 24 dm3. Calculate the number of moles. So they have given in cm3, but we have to do it in dm. How to convert cm3 into dm3? Once dm3 is equal to 1000 cm3. So we have to divide 20 into 10 to the power minus 3 over 24 dm3. 20 into 10 to the power minus 3 divided by 24 is 8.33 to 10 to the power minus 4. 8.33 into 10 to the power minus 4 moles. Okay, now let's continue this question to one of the interesting questions we have in syllabus. This is what they do in our exams. Check this question. Try to pause the video and try this question. If you can't do it, unpause and continue the video. So calculate the number of moles. We did that. It's 8.333 into 10 to the power minus 4. Let's write it down. 8.33 into 10 to the power minus 4 moles. Now this is a molecule. We have to calculate the number of, this is moles of molecule. So now we know its fluorine is a molecule and they are asking number of atoms. So fluorine each has 2 atoms. 8.33. Now how to calculate number of molecules? We multiply the number of moles we calculated in the earlier question by the Avogadro constant. So here we are calculating number of atoms. So we multiply by 2 because when we count the number of atoms in fluorine, fluorine looks like this. Fluorine molecule is like this. So there are 2 atoms in one molecule times the Avogadro constant 6.02 into 10 to the power 23. 8.33 into 10 to the power minus 4 into 2 into 6.02 into 10 to the power 50. Answer is there are 1.002 into 10 to the power 21 atoms. Okay. Now let's go into the next part of the chemical calculations. That's calculating concentration. Concentration is equal to number of moles is equal to also CV. We can calculate it further by P over Pm is equal to M over Mr is equal to CV because all these are methods of calculating number of moles. This one could be calculating number of moles, this one, or either this one. All these are methods of calculating number of moles. We'll go to an advanced question later on, which is a combined question, which they rarely ask, but they can also ask. So let's calculate number of moles when they have given the concentration and volume. How to calculate? Now the concentration, we'll learn about concentration first. Concentration is the number of particles present in a specific volume. Number of molecules, particles, atoms present in a specific amount of volume. So the volume does not change, only the number of particles change. Now when the number of particles change, concentration increases. But as soon as the volume increases, concentration decreases. The volume shows an inverse proportional relationship to concentration. Because when you increase volume, while keeping the number of particles the same, the concentration decreases. See this example? There are four piece atoms or molecules, let's say HCl molecules. We have 5 molecules of HCl. And we have around 6 molecules of water. This order. 5 molecules of water and 5 molecules of let's say 5 molecules of water and 6 molecules of HCl. Now the HCl is high, therefore the concentration of HCl in water is high. But what if we increase the number of molecules of H2O? There are 7 molecules of H2O and then 6 molecules of HCl. The HCl number of molecules same, but the volume has increased. Therefore, number of particles of HCl considered to the ratio of volume has decreased. So in that case, if for an example, to calculate concentration, there is 0.05 moles of HCl of volume 15 DMC. 0.05 divided by 15 would be 3.33 into 10 to the power minus 3. That's going to be 0.0003 mole per dm3. That's the accepted unit for concentration. Mole per dm3. Now try this question. Here's a tricky question. Here's a tricky question. You can start doing this question. Pause the video just to start doing it. So if you can't do it, here's a tricky question that you can try. Try pausing the video and doing the question. This is quite a tricky question, so better to try it out. Okay, so concentration is equal to, N divided by volume. They have given the volume, but no number of moles. We have to calculate it. So calculate the concentration of 20 grams of NaCl. M over MR, number of moles, is equal to, we'll type it. Number of moles is equal to M divided by MR. We all know that. So after calculating that number of moles, we are able to calculate the concentration. Concentration is equal to N divided by the volume. There we go. That's the working we are going to do. The working part. Okay. So first of all, 20 grams divided by sodium, it's 22.98 plus chlorine is 32, chlorine is 35.4, 35.4, let's say 35.5, and that 20 divided by 22.9 plus 35.5. The answer is 0.3419 mole. Then we'll calculate the number of moles now here. N is 0.3419 moles. We calculate the first step. Now we'll calculate the concentration. Concentration is equal to N over V, and it should be, the volume should be always in dm3. 1 dm3 is 1000 cm3, so 20 into 10 to the power minus minus 3, 10 to the power minus 3, to the power minus 3, 10 to the power minus 3, 20 to 10 to the power minus 3 is the volume, because we are getting in 3, divided by 0.3419. So divide that entire value by 20 into 10 to the power minus 3, which will be equal to 17.09. Concentration is 17.09 mole per dm3. Let's see if we have done any mistakes. So we are humans, we can do errors. Let's see. 20 grams of NaCl. Now this is how we calculated it. in November 20 grams divided by number 22.89 plus 35.5. That's going to be 58. 58.3. Let's get it as 58.3. Then we get 20 divided by 58.3 is 0.34 moles. 0.34 moles. Number of moles calculated. 0.34 divided by 20 into 10 to the power minus 3. We have to get it in dn3. 1 dn3 is equal to 1000 cm. So 1 cm3 is equal to 0.001 dn3 divided by 20 into 10 to the power minus 3. Answer is 17.15. The moles per, write the unit, moles per dn3. There. That's the answer for this question. And we have covered how to calculate number of moles using the standard method in NOVA-INMAR, how to calculate number of particles, ions, formula units of any substance using the Avogadro's constant, why Avogadro constant is used, how Avogadro's constant is used, Avogadro's constant related questions relating most of the advanced questions that we are going to do, and how to calculate concentration, how to calculate number of moles using the volume of a specific gas and the molar volume. We calculate most of the things that we require for this section. So that's it. And if you have any doubts, please, you're free to comment down below and those answer soon as uh, possible to you. And there's an available tutorial for this lesson, and you can purchase it in our teacher website, which will be available very soon. And have a nice day and stay tuned.